So thanks everyone, and I like to, as we go through this presentation, if there's any questions you have, or if I'm not making sense, put a question in the chat box, and I'm sure someone will interrupt me to get your question answered. So we're talking cover crops, and we'll get her going here. So fall planted cover crops. Okay, I was stumbling at the last minute. I realized I'm leaving our old department logo on here. So interestingly, we are no longer the Department of Soil Science, but the Department of Soil and Environmental Sciences, to reflect a broader array of research that we do. So today too, I want to just acknowledge some co-authors. There's been a lot of people that have worked on cover crops. Ashley Wagoner and Monica Schauer using a lot of the data here. The research funding provided by the USDA, National Institute of Food and Ag, but also from the Wisconsin Fertilizer Research Council. So I want to make sure everyone knows that those are important funding agencies. They fund the work like this that I'll present today. All right, so here's a corn silage. It's happening right now. Great opportunity to get cover crops out, right? A lot of people, it's exposed soil, not a lot of residue, hardly any residue. So an opportunity to get cover crops out. So you got a field like this. What should you do? So the corn silage situation usually comes with a fall manure application, right? So this is also a great opportunity to get manure applied. We see a lot of manure applied in the fall, but that comes with some drawbacks, right? So the one drawback is the fact that we can have more nitrate leaching over the fall and winter months. So I always like to show this slide which is it's a big meta-analysis conducted a few years ago that demonstrate any of the non-legume cover crops do a fantastic job. If you can get them established well, they will have positive benefits to reducing nitrate leaching to water quality. So in this case, what they're seeing is on average a 50% reduction across all the studies in the United States, demonstrating that if you use generally a grass cover crop, you're going to reduce nitrate leaching. Right? Makes sense. We have a plant out there. It's taking up nitrogen, less nitrogen leached out. The other thing is a more, well, it's not so recent anymore, but a meta-analysis of like this benefit of using cover crops to the soil. So here's one on looking at the changes in carbon. And so there's a lot going on here, but essentially across all the studies that they felt were conducted well, you can see pointing at grass, and this positive value here implies that you can see across all these studies maybe a 15% increase in soil carbon with continual use of grass cover crops. And in a smaller set of studies, actually with mixtures, tend to be even a little bit higher. Although generally with mixtures, those are going to be ones that are going to get planted a little bit earlier, so they tend to put on a little more biomass. But so we have these benefits that we want to extract from cover crops, right? They're going to help us with achieving water quality goals. They could help us with some soil health, soil carbon gains, or at least maintenance. But we need to ask some questions, right? So if we're going to use grass cover crops, which grass cover crops, right? Which cover crop species are right for you? Will cover crops influence your nutrient management plan? And that's going to be a big one. We talk about these cover crops taking up nitrogen, right? Good for water quality, but does that mean there's less nitrogen available for that next corn crop? And as you would expect, yeah, there might be. We can go through some of our updated recommendations on that. And then lastly is what seeding rate should you use? Do you want to seed heavy, try to put on a lot of biomass? Can you cut back? What's kind of the sweet spot? So as we reviewed, so we've done a lot of cover crop trials around Wisconsin at our ag experiment stations, and just kind of wanted to just talk through a few of the common species used. So, for example, or you go back down the left, no cover crop. It's like, man, that's really a lot of exposed soil, some, potential for erosion to occur. Wow, I'm all over the place with my slide movement here. Okay. What about cover crops? What are the entry cover crop really to me would be something like spring barley or oats. So these would be ones that you can plant. You can plant now. They're going to grow pretty well, but they're going to winter kill. So you can get nice establishment. They grow quickly, but then in the spring, it can be kind of hit or miss if you have enough dead biomass coverage to provide, erosion control, or if that's enough residue on the soil surface of, to achieve any of the goals that you'd like to see. But then the positive aspect is that you don't have to go out and terminate. So they winter kill. And we've seen, across our studies, generally, almost entirely across at least the studies I've done, spring barley and oats have winter killed. So those are a nice starter one. Annual ryegrass has also been talked about a lot. And again, this is different from winter rye or cereal rye. So annual ryegrass. And across all of our studies in Wisconsin, we see a lot of stuff like this where, sometimes it dies, sometimes it doesn't, but really it's more about it grows like parts of the field grew back. You can see in this picture, parts of that cover crop strip had the annual ryegrass had continued to grow. These pictures are taken in the spring, but a lot of the field is dead. And so that kind of puts it in a tough spot where it's like, well, can we predict if it's going to survive or not? And then, of course, winter rye, probably the most popular one in our studies, always have survived the winter. In this picture, this was seeded at a rate between 70 to 90 pounds. Nice thick stand. You have continued soil coverage in the spring, right? Continued potential benefits to trapping nitrogen, and we'll have obviously more growth and more carbon return to the soil. But that comes with the trade-off of you have to go out and terminate this cover crop. Typically, chemically. You can also use tillage, but most people are using this in conjunction with no-till, so they'll spray it off. So across all of our studies, we saw, apologies for the metric units, but they convert pretty similar to pounds per acre. So we can look at on average, so we did research at Arlington, Lancaster, and Marshfield. Generally speaking, we're getting anywhere between 2,000 to 3,000 pounds of dry matter biomass with winter rye. So it tends to be almost, in some cases, almost double that of the other cover crops. Annual ryegrass and barley, for example, tend to get close to 1,000 and often a little over 1,000 pounds of dry matter biomass, about half a ton. But so that's the biomass, but what about the nitrogen uptake as well? So you can see, though, we have a case where, on average, with 3,000 pounds of dry matter, we're getting about 80 pounds of nitrogen taken up in the above ground biomass. So trade-offs. So more growth means more nitrogen uptake. Less growth means less nitrogen uptake, but also less soil coverage. So when you think about which cover crop species is right for you, it really comes to the idea of how much growth are you going to get in the fall? Do you expect, are you going to get enough biomass coverage with spring barley or oats to get some erosion control, to get some water quality? Are you getting any benefits out of it? And it's all about growth. If you can get it to establish well, that might be a great situation to start. And for those then want to try to achieve some other benefits in the spring with continued cover crop growth with winter rye, those will have an even greater benefit to water quality. But, as I said, so thinking about, okay, let's tie these things together: cover crops, manure, and nutrient management. So if you're applying manure in the fall, you're planting a cover crop, how should you adjust your next, if you're planting corn, especially if it's corn is the next crop, what sort of considerations do you need to make for the amount of nitrogen you apply to that corn crop? So, this is the overall hypothesis here, right? This would be the best case situation was that the cover crops would only take up the nitrogen from the manure that was going to leach out anyway, and leave that remaining amount for that next corn crop, right? And in this case, it would imply we wouldn't have to adjust anything with your nutrient management plan. You wouldn't have to adjust any of your manure nitrogen credits. But what we're going to find here is that's generally not the case. Cover crops do take up nitrogen that was going to leach out, but they also tap into the amount that we would expect to be available for that next corn crop. And so we did this through a whole series of studies. This is an example from one year at our Lancaster experiment station in Grant County. This is a nitrogen rate trials. So here's our response curve when we stop using my mouse there. This is our response curve when we're not using a cover crop, right? So you can see it's flat. And this is a situation where all of the manure from the fall was available to that next. So in fact, the available N from that manure is maybe even larger than we expected. But when we use that cover crop with winter rye, you can see it taps into it. We needed 115 more pounds of nitrogen to maximize yields in this situation. And you'll probably also notice we lost some yield. So this is a case where we put on the most biomass across our studies. It was in that 3,000 or more pound range, where it started to become detrimental to that next crop. So we need a lot more nitrogen, and we had a little bit of a yield decline. So let's address both of those things. So first, we want to address the nitrogen issue, right? So we did all of these nitrogen rate studies, and we compared them from between cover crop use versus no cover crop use. And so we can graph things like this, where this is the change in the optimum nitrogen rate compared to the total amount of cover crop biomass at termination. And you can see there's a positive but somewhat weak relationship between the more biomass that cover crop puts on, the greater value here implies the more nitrogen is needed. So we have cases where once we kind of exceed that 2,000 pound threshold, we start to see situations where it's wiping out that manure nitrogen credit, and we have to really make sure we're supplying, a fair amount of nitrogen back through commercial fertilizer that next spring. And most of the work would imply that is connected to the total amount of biomass. So then we put all these together, and here's our here's our recommendations. So we think if you have less than 1,000 pounds of biomass out there, it should be fine. We really didn't see the cases where there were real adjustments needed to the manure nitrogen credit were rare. We don't think that's needed. When it's above 2,000, this case right here, we're going to have greater than 50 pounds taken up. And in most of those cases, we feel the risk is too high. I would suggest not taking the manure nitrogen credit. And we can talk about that a little bit more too. But and then kind of that 1,000, 2,000, that's kind of that mid-range where it's going to take up a certain amount. It's going to tap into it. Yes, it will vary from year to year. Here, we're saying on average, where you want to subtract about 35 pounds from your manure nitrogen credit. So whatever you were expecting from your manure, subtract off 35 pounds, and that's probably how much nitrogen from the manure is going to be available to that next crop. So this is but the whole thing here is that it does relate to the amount of cover crop biomass. So it would be important to go out, take a cover crop biomass sample, see if you can get a sense of how much biomass you've put on, and that'll help you adjust. So in a field that's really gotten away from you, above, you have over a ton, 3,000 pounds of dry matter. Yep, that's really taken up a lot of the nitrogen. Now, then that leads to this case where, okay, so what do we want? We want cover crop biomass to provide erosion control, but we don't want so much that it's going to cause problems for the next crop. So how do we keep it certainly below, to that, close to 1,000, but try to keep it to that certainly less than 2,000 pounds of biomass? So that would be, one is terminate early as possible. I always recommend whatever field you have winter rye on, you want to try to prioritize that field. Is like that's the first field you got to get to terminate that cover crop. Easier said than done year to year, of course. But the other thing that we can do is how low can we go with the seeding rate? If we get a cover crop out there, if we reduce the seeding rates, how low can we go to still maintain some positive benefits without having this nitrogen issue? Okay, and we'll talk a little bit about that, but there is this aspect of, is the cover crop, if the cover crop taps into the manure nitrogen, is this a good thing or bad thing? And, I can make the case for both, right? The case for good is that we have a lot of manure that needs to be land applied at some point. We'd rather have the manure tied up in plant biomass rather than have it leach out. And if you're concerned that you're not really getting a lot of credit from the manure, great. You'll never have to worry about it, right? Grow a ton of biomass, wipe out that manure credit, have that nitrogen trapped in the cover crop biomass, have it be beneficial to, building organic matter over time. Perhaps that's a benefit. Now, the case for the bad, though, is that if you are relying heavily on your manure as your source of nitrogen, it will tap into it, right? So it's going to reduce the economic value of that applied manure. So I use this phrase a lot, right? There's a price to be paid to the conservation gods, and that the price is in nitrogen. But I do think we can have some savings. We can save some investment, of the upfront cost of the cover crop itself by reducing seeding rates, as well as maybe reducing those negative effects. And this is some work that was conducted by Monica Schauer, where we put out different seeding rates. So we went as high as 120 pounds per acre of rye. This was all conducted under winter rye, and as low as 30. And so you can see, so we did this across 2 seasons. And when you can see in our first year, we really didn't have much biomass put on above the 60-pound seeding rate. And so what's interesting about these seeding rates too is that it's not uniformly distributed. When we change the seeding rate, we're still drill seeding these. All we're doing is changing that. We're just reducing that spacing, that plant to plant spacing. So at a certain point in time, things kind of even out. But in this case, in the first year, this was a case where we had maybe about 1,200, 1,300 pounds of dry matter, but we got just above 1,000 pounds of dry matter with that 30-pound seeding rate. So, and with 1,000 pounds, we are getting a decent amount of coverage. So we also took a lot of photos and evaluated it for what is the percent green coverage, and this is kind of something we're interested in. So what do we get? We get a couple hundred more pounds of dry matter biomass when we seed above 30, when we go 30 to 60. And we get about, in this case, we got 12% more green coverage or soil coverage with that increase. So that's the trade-off, right? And then not a real big difference above 60. Okay, and is 60% good enough? Maybe, maybe not. What do we want to achieve in most years? This was an example of one growing season. Let's get to this. Conduct the study again. Slightly different results. We do see we saw more of a linear increase where the greater the seeding rates, the more biomass. So what's interesting with the lower seeding rate, like the 30-pound seeding rate, less biomass, but interestingly, slightly taller plants. So each individual plant may grow a little bit larger, but as we add more and more plants, it might be shorter, but still the total amount of biomass is increased. So here, another case, we're between 1,000 and 1,500, kind of a nice sweet spot there, versus, getting close to that 2,000-pound range, which we want to keep it below that with a really high seeding rate. And in this case, wonderful coverage, a little bit better, right? 75% soil coverage with a 30-pound rate in the spring compared to once we go up to 60%, we get close to, or 60 pounds per acre, closer to that 87%. So, are we getting enough? And that's, that's obviously for everyone to decide. If you want to increase that seeding rate, you're going to get a little more biomass, but maybe you get a little more value out of that little extra coverage. But that's the trade-off. And I do want to mention this because Monica did a lot of work of measuring roots, and there's a lot more biomass out there than generally we're given credit for. All those numbers I gave before were just the above ground biomass, but we have a situation where that below ground biomass is adding a lot of carbon to the soil too. So when we think about like the total biomass, anywhere between 50 to 100% of the above ground biomass is actually occurring, is actually equivalent below ground biomass. So if you add in the below ground biomass, you're adding a lot more total biomass as well as total nitrogen uptake. So more things to think about. Not only are we increasing the biomass, we're increasing the total amount of N uptake as we increase the seeding rate. All right, so what does all this mean? So let's just step back. Spring barley and oats, good options as a starter cover crop. Try it, see if they like it. It's more of an operation, see how well it's growing. These are sort of long-term trial and error type situations. Then if you feel comfortable, go into winter rye, get that coverage in the spring. Overall, generally good, but it's going to take some practice, right? All those little things that you need to do as you're farming and getting better and better as you add more practices to your crop rotations. Definitely need to adjust manure nitrogen credits. So use those. Those are real, and those are getting built into the next version of Snap Plus. And I would say there's no real value in seeding above 60 pounds. If you want to seed higher, you would be wanting to do that for some sort of bigger soil health, soil carbon gain type goals. But even then, there's the risk reward above 60, to me, isn't worth it. Keep it to 60, and even you can play around with below 60 if you're drill seeding. And the elephant in the room is, well, what's the manure nitrogen credit with fall manure? And that number is actually more variable than we probably give it credit for. So if you think you're not really getting that value out of that fall manure, compared to the book values, use cover crops. If you're not getting much value out of that nitrogen anyway, use cover crops, take it up. I'd rather have that, we would rather have that nitrogen trapped in biomass, in cover crop biomass, benefiting the soil than leaching the groundwater. So with that, that's kind of the all the big messages for the day. And if anyone has any thoughts or questions or concerns, anyone disagree, happy to chat more.
Well, thank you, Matt, for hopping on today and providing that information. I don't see any questions in the chat box. And I know you have to scoot, I think, in a few minutes here. So if we don't have any questions, we'll get your email in the chat, and maybe some will come your way after folks have a little bit of time to think about your information.
Sounds good.
All right. Thanks again,
And
Matt.
actually, I will be around. I'll be able to stick around now. So if anyone has any additional questions come to mind, I know this group is not shy. So
all right. Yeah. Well, thanks again, Matt, for hanging around then.